Good morning. Welcome to another Morning Coffee with Trevor. I'm your host, Trevor Matthews, and it's been a great week. This week has flew by. I've learned a lot, and what I'm really proud of about myself this week is planning my week and planning my days and scheduling myself, which has taken a lot of work over the last couple of months, to be honest. And I'm finally getting into the routine of hitting my goals. Like this morning, I got up at 5, was able to get my workout in, hit a shower, get my coffee ready, and prep for this. And this is the last 10 days been going very well. And there's still a lot of work that I need to do on my planning and prepping for my day, because one of the things that I'm working on is trying to get enough sleep. I want to get to the point where I get 7 hours of sleep a night. So that gives me, 17 hours in a day to get stuff done, and having enough rest. Depending on who you talk to, some people say you need 6 hours of sleep, 7 hours of sleep, or 8 hours of sleep. I feel like when I get 8 hours of sleep, when the kids in my bed kicking me and stuff, it gives me enough energy for waking up. So when I get up at 5 o'clock in the morning, that I don't feel really tired and like sluggish, and I can get up at 5 and I can do my workout, and then plan my day and get my stuff done. And over the last 10 days, that's been working, because 2 weeks ago I was getting up at 6:30 and for a few days, and then it took a lot longer to get back into the routine of getting up at 5. So it's some habits that you need to get involved in, and it's been working out quite well. So good morning, everyone. Thanks for joining. Over the last 10 days, we talked about many different technical topics and personal development stuff, but we're going to get back into a bit of a technical stuff, because I'm building a lot of content, and I'm trying to focus on scheduling those 17 hours a day that I have on, wealth, health, family, and trying to make sure that I can put all of that in there, like social time, talking with friends and family. And it's, when you think about it, it sounds like you have a lot of time, but you can burn up that time very quickly. Like, I can spend time on building content for the training programs that I have, and it takes a while to do that stuff. So, you're sitting there because you want to make it right. I want to bring the right point across, and I want to make sure that the information that I'm sharing with technicians, refrigeration professionals, that they are comprehending it very easily, like complex, situation, troubleshooting, system design, that it's easy for them to understand and digest. And I think that's the biggest thing that I'm trying to do, is two things: make refrigeration fun, learning it, as well as making it easy to learn. And it's a juggling act when you're building content. Today, I'm going to talk a little bit about refrigeration piping and the understanding why it's important to understand what's going on when a system is designed, because that's something that, as a technician, you'll learn and you review it a little bit, and you may do some pipe sizing at the trade school you go to, if you went to a trade school, if you had the opportunity to do that. But it's something you don't spend a lot of time on, and it's things that you will see over time when you have issues that is caused from the piping or from the design. One of the examples is in the main line, you're sizing discharge lines, you're sizing liquid lines, you're sizing suction lines when you're installing your own equipment. And the big one that you really need to understand is really the suction line, because that one there is, you want to ensure that oil is coming back. And when you don't have the proper size lines, you're going to run into issues. And it could be lots of different things that will make you chase your tail for a while. For example, I got a Keep Right manual out here, and I highly recommend you read a lot of the manuals that these condensing unit manufacturers or these rack manufacturers put out there, because there is so much great information. There's a lot of gray stuff in there too, to be honest, where they don't say their exact point or to say exactly how something works. I've read lots of them, but it's a great starting point. And as long as you're following what these manufacturers are suggesting, especially the big ones, because they have they have a lot of detail in there, and they're thick sometimes, and it's intimidating, and they're long, and you're skipping pages. But I highly recommend you start from the front and get to the end at some point, because if you start skipping stuff, you're going to miss things here and there. And so for piping, for example, in this Keep Right one, like suction line should be sized on the basis of the maximum total pressure drop equivalent of 2 degrees Fahrenheit, a change in the saturating temperature. And really what that means, if you have a higher pressure drop in that, there's potential chance you're not going to get that oil back. And I've had many conversations with manufacturers and designers of systems where they send out their equipment and the contractor installed it not following these, and then sometimes having pressure drops up to 12 to 15 psi in a suction line. That is a huge pressure drop. And now you're trying to get oil back, and oil doesn't travel as well with gas as it does with liquid. And so you need to understand that. And when you have huge pressure drops, why do you have it? Is it that suction line that is not correct? And then there's lots of other things that affect the oil. It's like the way it's sloped. Is it sloped properly? And you got to figure that out. I've done so many installs, and I've seen it many times where it looks like it's sloped when you're looking back from it. But when you go up there and you actually put a level on it and you check it, it's not sloped the right way, because it can be with insulation on there. The insulation might not be on properly, might have different size insulation. Hopefully you don't. You have the same size insulation, but you want to make sure it's sloped properly. And, depending on what books you read, it's someone's going to say, a half inch for every 10 feet of slope, back to the compressor. Some will say quarter inch per 10 feet. And then if you're doing it in metric, it's 12 mils per 3 meters and 12 millimeters. But this is something that is important, because if you don't have that slope back, that oil, is going to start to flow. Its gravity is fed back, and it's going to slowly trickle back to that, your compressor. And you need to get that oil back for that compressor, that lubrication. If you don't, you're going to run into issues. But that's really the easy parts. Going up and sloping is the easy parts. The difficult parts where it comes in is that you need to size the lines per the refrigerant and per the velocity of that refrigerant traveling through the pipes. For like suction lines, that in the example, and here in Keep Right, they say should not be less than 1,000 feet per minute or 5 meters per second, preferably 1,250 to 1,500 feet per minute, or 6 meters to 8 meters per second. And the reason is that you need that flow. You need that oil to be brought back to the compressor. When you talk about low temp applications or really, really long pipe runs, that's why they add different components like oil management system, oil separators, oil reservoirs, all these different components to keep the oil back at that rack or that parallel system, because especially in low temp application, the oil gets really viscous, it gets thick, it's like molasses, and then it can start logging in the system. And oil, once again, is one thing that's really hard to troubleshoot for a lot of technicians. It was really hard for me, even now, with all the experience I have. Oil is still a difficult thing to look at, because there's so many different components, especially on a system with oil management system, because you got a lot of screens, you got oil feeds, you got pots, you could got OMBs, OMCs, OM whatever, OM5s, and then floats in maybe the oil management system and the reservoir, whatever it is, the oil filter. So there's a lot of different things. So understanding the piping is very, very important. Another one is in the liquid line. You need to understand what your velocities in your liquid line, because if you have too high a velocity, if you've ever been on a site and you hear like that, when that solenoid opens up and then closes and there's big bangs and the liquid line shaking, you're probably getting something called liquid hammering. And the velocity is probably too high. It's over that 300 feet per second. So that's something, if you see that and that's happening every time that solenoid opens and closes, and that liquid line makes a loud noise and it starts to shake, you may have too much velocity in there, and you should check the line sizing of that equipment. Because when you're trying to move, say you get risers going up, there's feet of head, you got to push that liquid up, and you need to understand that as well. And when you have long runs, so all this stuff comes into play for getting that oil back. And different designers are going to have different little uniquenesses the way they do it. Someone's going to say like, oh, I need 275 feet per second for my liquid line. Some other will say it's 225 that I need. And there's a range, but you don't want to have in the liquid line it too much. Anybody here sized system before? Did any line size and have any experience with that, or any issues with systems with oil? That's okay. That is okay. So another thing in their manual, they talk about P-traps. Depending on where you're at, there's going to be different rules depending on your codes and stuff and your refrigeration codes. It's going to say in there, like I know when I worked out in Alberta, I believe it was if it's over 5 feet, there should be a trap in the refrigeration one. So if you have it over 5 feet, and you should have a trap. And really what a trap is that you have like 3 elbows, and one points down, one points to the right, and then one points up. And so what you're trying to do is reduce the velocity. So you get oil that fills up in there, reduce the velocity so that as that comes through into the suction, it gives enough velocity to pull that oil back. And there's incorrect ways to build a trap and proper ways to build a trap. And I know there's specific traps that you can just buy. You can already buy a pre-built trap, and I recommend doing that too if you can. I'm sure they're more expensive, but if you put the bushing at the front of the trap, you're going to run into issues potentially. And I've done that before where I had to change them because I didn't know the difference. And what you want to do is really reduce that suction line riser. So if it's 1'1", just say you do the sizing, and the riser needs to be reduced down to 7/8. It should be just the bushing on the vertical going up, and that should be a 7/8, a line going up. And then at the top, you should have 7/8 going up, and then you're bushing there. So you shouldn't have the bushing on the vertical. It should, again, be on the horizontal. And that's some of the proper practices that engineers showed me. And you can read this in books. A lot of this information I learned right out of the Copeland manual on system design. And this is an old book, but refrigeration hasn't really changed. Refrigeration is refrigeration. And like piping hasn't really changed, because you still need that amount of velocity. You need that velocity going through the system to get that oil back. And this is something that we need to understand as a technician, because this is those problems where it's going to take you a long time to troubleshoot, because you're not thinking, okay, well, this system's been running for 3 years. There shouldn't be anything wrong with it. It doesn't mean it wasn't installed wrong and it just got by for the last 3 years. I've seen that so many times. Well, it's been working for 2 years. It must be wrong. Or this system right beside it is the exact same system as this, and it all looks the same, but there's something different. Maybe the insulation looks the same, but the pipe underneath the insulation is the wrong side. I've seen it with hot gas defrost systems a ton, where it should have been 7/8 lines and people put in 5/8 lines. And I've even done it because that's what I was told to put in, and then ran into defrost issues. So piping is super important. And when you start to get with capacity control, it's even more important, because when you have capacity control compressors, you're reducing the amount of mass flow happening, the velocity through those pipes. And when you do that, is that you may need to have something called a double riser, right? So when your capacity gets down to 25%, that you have enough velocity going up the risers to get that oil back. And it's important to look at that stuff. And how to pipe it is very important as well. How to properly pipe it, how to properly have the tees. You know, liquid lines should be pointing down, suctions up. I've seen that a lot of the times where they were wrong and ran into issues, right? Because you want that full column of liquid going down. You'll see on any header, liquid header, all the liquid lines come down, you know, in cases pointing down. You want that, so you're always getting a good quality of liquid. So I got a question here. I have some fuzziness. We purchased the traps. I question why the excessive insulation though. Okay, so I'm not sure of the P trap, but it all depends on application. Like for low temp applications, when I was working there, it was spec for 3/4 or 1-inch insulation, because you want to really not have any infiltration of heat in there. So you don't want to be picking up any heat back to the compressor. So the thicker the insulation, the better, especially for low temp application. You would see that applications that I've worked in, you want to have thicker insulation than even medium temp. It costs a lot of money. Insulation is not cheap. I know I've talked to some people and it says it's very expensive right now, but what you want to make sure is that it's insulated properly. You have the proper glue around it and it's sealed properly. The insulation sealed, because I've seen it a lot of times when you look up and all of a sudden there's a big ball of ice, and what happens, it's just heat, moisture starts to get in there and starts to build some ice, a little bit of ice, and then it starts to break that insulation apart. And then when it goes into a defrost or something, it starts to drip on top of customers or employees there. So I don't know if that answers your question, because I haven't seen P traps that were already insulated, but they're probably for preparing you for low temp applications. So some more things about line sizing. You know, the horizontal liquid line should be sized based on the maximum pressure of 2 degrees Fahrenheit. So I said that already. Okay, the vertical lines. So if the lines travel up vertically, then adequate subcooling must be provided to overcome that vertical liquid head pressure. So this is when we're talking about those vertical. So if it's 10 feet, 20 feet, 30 feet risers, you know, a head of 2 feet of liquid refrigerant is approximately 1 psi, is equivalent to 1 psi. So for example, if you're going up 30 feet, that's about 15 psi pressure drop. So you need to really have enough subcooling to overcome that. So you have enough liquid refrigerant getting to that metering device, so you don't have any flash gas. So these are things that you don't always think about. Maybe you learn about when you first start out in the industry, but over time it's something that you don't see every day and you don't do every day, and it's something that you should be thinking about. Any questions on that? There are some good line sizing manuals out there. There's good line sizing software, depending on if you're, you know, you're just doing one system and you want to check it out. There's HVACR advisors. Andy Scowen, I think his name is, very smart guy. Been in the industry and developed lots of different programs. I believe he worked with Sporlan for many years and many other big brands in the refrigeration. But you can go and check out his line sizing software if you just want to, you know, verify, see if you're getting the right velocity in your suction, in your liquid, in your discharge. There's other books if you want to do it manual, and I highly recommend, you know, just plotting it out, you know, on a chart, just so you learn and you get a better understanding on how that works. And there's, like, I know I used to use one from DuPont. You probably can still find it online. So look up DuPont line sizing software. It's an older manual, but it had all the main refrigerants at that point. I don't know if it would be updated like Andy's software. And then if you're an engineer or a refrigeration designer, I'm working with a great guy out of the UK. His name's James Bailey. And he has a software called MicroPipe, where if you're designing a whole system, you know, instead of having to go to the charts and you want to design and develop a whole piping system for a rack application on CO2, or if you're doing a plant, an industrial plant, the software will do all of that for you. You know, all the line sizings, the risers, the traps, and it's a really cool software. We're doing a training on March 1st. I'll actually put the training link in there, free training to see the software in action. He's going to do a couple demos for any designers or engineers looking to learn more how to do sizing on CO2 applications, as well as if you want to learn how it's done, you know. So it's pretty cool stuff. It's a lot of fun learning these different things from engineers for me, because it gives me a broader look at the industry and gives me more things to think about from my side as a technician to where the engineers and manufacturers are looking at. And this is the same with a lot of your companies as well. You probably have designers in your organization doing this stuff. So strike up a conversation with them, you know, find out when if there's something going on with a system, ask them questions on it. You know what I mean? See if they can, you know, answer the questions like that. Well, what should the velocity be in this line? You know what I mean? I'm getting liquid hammering. What should it be? You know, or call up the manufacturer of that equipment and ask these questions. I know Heatcraft. I have another book from Heatcraft. I can't remember. Maybe it's the load calculations, an older one. It's like maybe 12, 15 years old, this book, but it's a great line sizing software, book, where it talks about all of this stuff as well inside that book from Heatcraft. I'll have to look it up and pull it out of my library, but it talks about like all the different products and what temperature they should be hold at for how long and how long they last, because that's super important to understand the different process and the different temperatures of the different walk-in boxes and the different coolers and the different cases on how they should be kept. So I got a question here. When you have two evaporator blower system on a medium temp box, would it be feasible to have a thermostat for both blowers or one T-stat? Not really sure about that question. If you have a medium temp box and you have, say, two coils, really that system should shut down. Like the T-stat should close the solenoid for both of those if that's the way it's set up. If it's one solenoid, one liquid line in, one suction line out. If it's two liquid lines in, two suction lines out, I still would say you would cut both of those off to pump them down, because those ones should be equally loaded and you should have equal flow across them. That's if you have two coils. Hopefully that's the question you answered. Could you do it a different way? You could, but I think you would be loading the evaporators up a bit differently, right? And because you want to have the proper airflow across them. So a big thing about doing walk-ins is that you need to space those coils properly. You need to have them away from the wall properly, the proper distance per manufacturer's spec. And make sure you have that proper airflow, because I've seen it before where people put it too close, too far away, and you just don't get proper cooling, or should be always facing the door. If that the fans, if you have a lot of doors, say a bunch of glass doors in a dairy box, you'd have the fans pointing towards those doors that are being opened all the time. So if the box with just one main door, that airflow should be pointing towards that door. So if any time the door is open, it's pushing the air out, so you're not infiltrating heat in there. And you need to talk with the manufacturers. You also need to take a look at their specs and how they want you to install it, because they spend a lot of time designing these. But you want to look at other ones as well. You want to check multiple sources. Don't just use one source. Use multiple sources to understand that. Yeah, I would have one T-stat for that to, when you satisfy. If you have one solenoid, so one liquid line in, one liquid line out, just one T-stat for those both coils. Victor, how you doing today? Warm down in Aruba?
Yes, it's warm here. I don't know. You guys still cold over there?
Oh yeah, it's only maybe minus 20 Celsius today,
It's
minus
not
15.
bad.
It's fresh. It wakes you right up, that's for sure. When you walk
Yeah,
outside.
I think you should take a short and with a t-shirt and run outside.
Yeah. Oh yeah. Well, my studio and my office is actually outside, so it wakes me up coming into the studio, so it's pretty fun.
Yeah, early in the morning. Brr.
What are you working on? Are you working on any good projects right now, Victor?
Yeah, we're busy with hydro loop system with R290
Nice.
on a supermarket.
Are they so you're using the water loop? How many coils or cases do you have? Are they all in
17 cases.
17? Okay.
Yes.
I know one of the first ones that I've heard about was in the USA, like 300 cases. Wow. And they did a study on it, and they were like trying to compare the costs. And I want to look that back up and find out, after 4 or 5 years where the cost is, because it's just such a small charge in those ones there. The regulations have changed since then, right? You can have more R290 in systems. Well, in the US for sure. In Canada, I got to double check the regulations, but you can have more in there. So now it's making it more feasible to use these refrigerants.
Yeah, because all these systems are with variable speed compressors, VFDs, and electronic expansion valves. So
yeah, awesome. So whose compressor are you using? Scoop or Embraco or Copeland? Whose are you using?
Embraco. We have Embraco, Copeland, and yep. Siam.
Okay. Yeah, awesome. So you got a variety of it. What about the valves? Are they pulse valves? Are they stepper valves?
Stepper valve from Carrel.
Oh, cool. So good setup.
Yeah.
So that's going to be a lot of fun. So the big thing about that, I've done tons of electronic valves and variable speed. I've learned about lots of it, worked on it, and I've talked to all the manufacturers. Like I used to, when I worked at Emerson, I trained on electronic valves, but then I did talk to the guys at Carrel, and I talked to the guys at K2 and Sporlan. And it's the same thing. We have the same things when we're field supporting contractors. It's the wires are not properly connected.
Yeah.
They're running with high voltage wires. The parameters, one of the big things I highly recommend when you're talking to the technicians is they got to understand the parameters. Because one parameter misadjusted is going to affect that whole system.
Yeah, it's the same thing like one watt sensor. You don't control or you don't commission the system. One watt sensor can give you a lot of problems.
Yeah, so you got to take the time and show them, get them the instruction manuals and find the right ones. There might be multiple ones. So take the time to understand it. That's a cool application. I'd love to hear more about it throughout these trainings and these talks, I guess. And because that's something I'm trying to still develop my skills on. I've trained hundreds of mechanics on R290, and it's still evolving. The natural refrigerants are still evolving, and there's so much to learn on it. And I see that becoming a huge growth in the industry with that refrigerant as the regulations continue to change and stuff.
Like the new standard on what we're gonna have in our systems is on the coolers, 450 grams per unit. For freezers, 700 grams, and open type coolers is gonna be 650 grams.
Yeah. Okay. So that's the regulations there, and that's great because what you need to understand, it's going to be different. If you have closed doors, it's going to be a different regulation because the LEL, the limit, the lower explosive limit, is going to be different than when it's an open case. So these are all different things you need to learn as a technician, as a designer, as a an engineer, because you need to understand what's correct, what's regulation, and what's not, you know, because there's so much out there. So awesome. That's great. Continuing the learning is that is the.
Yeah, that's what we do every day. We continue learning.
Awesome. Awesome. Well, thank you everyone for joining again today. I had a great conversation, talked about piping, which is great, and a lot of other cool little things. Hopefully to see you tomorrow, and let's get another conversation going.
Thank you. Have a good day.